Brian Waple is the Armex business manager for the Armaclean Company and Church & Dwight Company, Inc., makers of Arm & Hammer products since 1846. Brian has over 20 years of specialty chemical industry experience in product and project management, technical support, and sales. Brian has been with Armex since 2014. Jeff Paduano is president of ESCA, a turnkey supplier of surface preparation equipment and supplies, which has been serving the industry for over a decade. ESCA was one of the original Armex soda blast dealers and has extensive knowledge regarding non-destructive, chemical-free cleaning methods. Jeff is a certified C7 abrasive blaster, graduated with a Bachelor of Science degree from State University of New York in ESCO. Brian and Jeff will talk about vapor blasting with baking soda, the different components that can be blasted, why you should consider this process, and what you will need to get started. Before I turn this over to Brian and Jeff, please remember that if you have any questions, you need to type them into the question box and we'll have them answer the questions at the end of their presentation. Now here's Brian Waple of Armex and Jeff Paduano of ESCA Industries.
Thank you, Joe, for the introduction. I'd also like to thank everybody for taking the time today to join us for this webinar.
Okay.
With that, we'll jump right into my portion of the webinar today. I'll be presenting vapor blasting with baking soda, along with the advantages this process provides in core and component cleaning prior to remanufacturing. Next slide, please. Okay, what is vapor blasting? Vapor blasting is a form of abrasive blasting that uses both pressurized air and water. It is different from dry blasting by the blast media is moistened prior to impacting the surface. The main advantage of vapor blasting over dry blasting is that vapor blasting reduces the dust and abrasive media consumption, all while increasing operator productivity. The results are more consistently clean surfaces with no embedded blast particles or clean dust left behind. Vapor blasting is also referred to as wet blasting, wet abrasive blasting, slurry blasting, wet sand blasting, and dustless blasting. Next slide, please. Here, why use baking soda? Now, in vapor blasting, many different forms of media can be used. However, in the remanufacturing and rebuilding sector, baking soda is your best option as far as an abrasive media in vapor blasting. The real advantage of baking soda is grease and oil removal. Baking soda loves grease and oils, all without, and the whole idea here is when you're using other medias, a lot of times you have to do a pre-treatment prior to, doing your blasting. With soda, you don't have to do that. Baking soda remove all your grease and oils without a pre-post chemical cleaning. Grease and oils dissolve better in an alkaline environment. Baking soda has a pH of 8.25, making it a mild alkaline material. During blasting in an alkaline environment creates a distribution of baking soda particles over the surface being cleaned. These particles are what actually absorbs all the oils and greases because the oil and greases favor the alkaline environment over the actual substrate. Only baking soda does this. Other blast medias will leave behind a film of grease or oils, requiring an additional, post-cleaning step to remove those type of contaminants. If you look at the pictures here, you can see the results on what baking soda can do with grease and oil. Vapor blasting with baking soda. Baking soda can be used in vapor blast equipment with no modifications needed to the equipment. That's very important because when you're dry blasting with baking soda, depending upon the type of equipment you're using, you usually have to use, baking soda, dedicated equipment, especially in the contained cabinet type equipments. How does it all work? Baking soda is introduced to the pressure vessel in the same manner as other blast medias. The change in the process from a hard media to baking soda is the need to slightly, change the differential pressure to a little bit higher to achieve the desired media flow rate from the equipment. This is not really a big surprise, mainly because baking soda is lighter in density than other blast medias used in vapor blasters. At the end of the workday, we advise that you purge the pressure vessel, removing all the baking soda from there. You do not want to leave the baking soda in your blast pot overnight. Obviously, baking soda is soluble. It will dissolve in water after a certain point, and then all your baking soda left in that pressure vessel can all dissolve, and you also have the potential of clogging some lines and things like that. So at the end of the day, you always want to remove your baking soda. What is the Armex difference as far as other types of sodas that are out there? Armex is actually the original baking soda abrasive. Armex first got its start in 1984 during the restoration project of Statue of Liberty in New York Harbor. In this project, the engineers were searching for a way to remove the 100-year-old coal tar epoxy without damaging Lady Liberty's delicate skin. During this process, the engineers tried mechanical abrasion, chemical abrasion, and of course, abrasive blasting, and they learned very quickly that the hard medias was penetrating the skin of the copper as well as damaging it. One of the engineers had the idea to try and use baking soda. They learned very quickly of the extraordinary cleaning properties, all not causing any surface damage. With the success of baking soda blasting, the engineers contacted Church & Dwight Company, makers of Arm & Hammer products since 1846, for assistance in the restoration. At the end of the restoration of Statue of Liberty, over 200,000 pounds of baking soda were used to clean the interior. Following this success, the Armex brand was launched in 1989, so we're closely approaching our 30-year anniversary. Armex is the only baking soda abrasive formulated and manufactured specifically for abrasive blasting. What does that mean? When we produce our baking soda for blasting, we're using particle sizes that are manufactured to a consistent size and distribution, and also we have value-increasing additives that are actually added to the baking soda called Moisture Guard. Why is Moisture Guard important? Moisture Guard aids in the flow and moisture control of baking soda when vapor blasting. It extends the life of the baking soda. The best way to kind of give you an analogy of how this Moisture Guard works, think of Moisture Guard as the hard candy shell on an M&M, and the chocolate in the center is the baking soda. What happens is the Moisture Guard helps in the longevity of the baking soda in the wet environment, preventing premature dissolving of the baking soda. Only Armex has this benefit. Also, depending upon what you're doing and what your contamination need to be cleaned, we have 3 different particle sizes, 70, 170, 270 microns. All these products can be used in a wet or dry application, and Armex is manufactured in the United States, in Ohio, and in Wyoming, and it is a Arm & Hammer product. The image there shows you kind of what the moisture control additive is all about. You can take baking soda, you can put it in a beaker there filled with water. You can then pour the beaker out into your hand, and the baking soda is still dry. That's the picture on the left. The right shows the ordinary baking soda, how it starts to dissolve within the water. For more information about Armex products and different types of uses for baking soda blasting, especially in the remanufacturing sector, visit our website. We have product information there, SDSs, product technical sheets, product case studies, news and events, and more importantly, we have FAQs. A lot of different questions can be answered, as well as our new resource library and videos. Armex is also on social media. We're on Facebook, LinkedIn, Instagram, Twitter, and YouTube. We have a YouTube channel called Armex Cleaning. On our social platforms, we promote all different types of uses of our products, events, product information, and of course stories related to vapor blasting as well as dry blasting. With that, I'll turn the rest of the presentation over to Jeff.
All right. Thank you, Brian. Thank you all for who's on the line. Good morning. It's a pleasure to be a part of this. Thank you, Joe and PERA, for organizing this webinar. So let's see. If you could, Brian, go to the next slide. And for those of you that may not have heard of ESCA before, this is just a snapshot of the company. We have been around for over 3 decades, and we were set up as one of the original Armex dealers back in the very early 90s. So we do consider ourselves soda blast experts. And since then, we have evolved quite a bit and are now involved with all things blasting. And you can see everything listed out that we do, but we are a supplier, not a contractor, and we do work with contractors, we work with corporations and government on various types of projects and operations. I am speaking to you from the home office here in Hatfield, Pennsylvania. We are real close to Philadelphia. We opened up a brand new branch office and warehouse in Grand Rapids, Michigan this year. Some of you may know the name Wayne Lawrence. He's running the show up there. He's been in this industry also for a very long time, over 20 years. We have a small facility in Charlotte, and we also have a couple technicians that come out of Chicago. One of the topics I'll be speaking about today is a project that we landed this year with a very large company in Illinois, and it was an indoor vapor blasting booth designed for the refurbishment and reman of large tanks and vessels. Next slide, please. So, you know, Brian covered the media, what goes into the equipment, and I'm going to speak to, say, the hardware and everything that one would really need to consider to do this right. Actually, I forgot to mention, so that picture of that motor that just shows it post soda blast cleaning. I don't have a before picture on this slide, but ultimately when that came to us, it was caked in grease and oil. This was sent to us from Canada, and that is one service that we offer. We have a very large testing center here at the home office, and it allows people to send us objects like this and parts and components, and then usually they visit us to watch the process themselves. So that's a standing offer to anyone that may have an interest in pursuing this further. You're more than welcome to follow up with us, to schedule a visit, to send us your parts. We're happy to show you the process so you can see it with your own eyes. Next slide, please. So this graphic just shows the main pieces of the puzzle. So regardless of your blast environment, meaning we work with some folks that actually do a lot of this work still outdoors, and the trend though is to bring it indoors. And no matter what though, indoors or outdoors, you will need these pieces of the puzzle: the air supply, maybe an air dryer, I'll talk about that, and then obviously a vapor blaster. Next slide, please. So in terms of air compressors, I would presume many of you on the line are already, working in a shop environment, and you probably have an air compressor in-house. So for those considering doing work like this, but they want to explore doing it outdoors in a yard, that's where you would be looking at a diesel-powered tow-behind compressor. For folks that don't already have shop air, that's obviously anything indoors is going to be an electric-style compressor. The question we receive a lot is how much air do I need? How large of a compressor would I need to perform this type of operation? So if you could go to the next slide, Brian. So this table answers that question. And if you start on the left side, the left column is showing nozzle number and how that correlates to orifice size. So a number 4 nozzle is a 1/4 inch opening. And then if you look at the top 2 rows, that is showing various blast pressures. And when someone is doing a reman project on a large motor, generally speaking, you are going to want to soda blast that piece at a high pressure, let's say 90 to 100 psi. And if you look at the numbers in the middle of the table, those are showing CFM requirements. And CFM is a way to measure the air compressor volume. So this has nothing to do with PSI, and that's the part that some people get caught up on. They'll call us and say, well, I have a shop compressor that goes at 100 PSI, and they just presume that's all that matters. But again, in this scenario, PSI does matter, but in order to achieve the right PSI, when it's combined with a certain size nozzle, you know, that's where you need to look at the size of the compressor, not its actual PSI rating. So just a little bit more on this. If we select a number 4 size nozzle, that would be suitable and work just fine for a smaller scale operation, maybe spot blasting or spot cleaning, maybe touch-up work, intermittent use, so not necessarily using the equipment on a regular daily basis. If that was your scenario, a number 4 nozzle would work just fine. And then if you go across the chart, and if you find the 90 or 100 PSI columns, those numbers you see there, 93 to 103, represents the amount of air you need in terms of CFM. So you can see right there, you need a minimum of 93 to do 90 PSI blasting. And if you wanted to step it up to 100, you need at least 103 CFM rating. That just shows you what you need to achieve that blast pressure. What that number does not take into account would be any other pneumatic operations that you have existing in your shop. So you need to factor that in when you're trying to size the compressor. And then you also want to factor in a cushion. So various compressor OEMs have various recommendations on the cushion. Generally speaking, it's a minimum of 20 to 25%, and we actually have heard some OEMs state they actually look for up to 50% of a cushion. But that's the range, 20 to 50% extra above and beyond your actual demand. And then just one more example here. So if you go down to the number 8 nozzle size, which is a 1/2 inch opening, and then go across again to the 90 or 100 PSI columns, you'll see the values 371 to 407. So you can see that's more than double of what you need with a number 4 nozzle. So that is a much larger air compressor that's needed. And again, that is what you need just to achieve the blasting pressure. And you still would go through that same exercise. What is the other demand in my plant that I need to account for? And then what type of cushion am I comfortable with? Next slide, please. So not going to spend too much time here, but we're hooked up. ESCA is an authorized distributor and dealer for the Kaiser brand. We've been associated with them for almost 10 years, but there's other good compressor OEMs out there. In some cases, it's a lot like buying a car. So if you are in the market for a compressor, we recommend that you pay attention to its efficiency. If it's a tow behind diesel operated, how many gallons per hour is it going to consume? And on the for an indoor compressor, a variable speed drive is going to run more efficiently than a fixed drive motor. So most portables today are already in compliance with the Tier 4 regulations that relate to emissions. And again, just that bottom section is just reiterating what I spoke about on the previous slide. Next slide, please. So back to the big picture. The air dryer has a question mark next to it because we are talking about vapor blasting. If instead our topic today was dedicated to dry soda blasting, there would be no question mark there. It's always a best practice whenever you're dry soda blasting to make sure that your air supply, your compressed air supply, is not only moisture free, but also contaminant free. And by contaminant free, I'm referring to any type of oil, traces of oil that might be in the airstream. So air compressors, by their very nature, as they're generating compressed air, part of that process, and it's basically a byproduct, is there is a trace amount of oil that ends up in the airstream. So if you think about what we're talking about today, cleaning parts and components and cores, degreasing them, generally speaking, you wouldn't necessarily want to add any extra oil into the equation. So we still recommend that people pay attention to the removal of any contaminants that are in the air supply. So if you're already in a shop environment with an electric compressor, my guess would be you already have this arrangement. You probably already have good, solid, quality air running through your plant. If instead you're looking at an outdoor operation that uses a diesel-powered compressor, typically those units do not have the air dryers built into them or even the oil removers. And to remove the oil, we're really just talking about the use of a coalescent filter. That's usually an aftermarket item. So just kind of raising a little awareness here. But the primary purpose of an air dryer, the removal of moisture from the airstream, that is not as critical. And for the obvious reason that, for most vapor blasters on the market today, you're adding water to the mixture already, so a little extra moisture really isn't going to make a difference. Next slide, please. Okay, so now, again, big picture here. We're going to discuss a little more in depth the actual vapor blasting equipment. Next slide, please. So Brian mentioned there's a couple different names today that are used, are interchangeable to discuss this technology, vapor blasting. A popular one is the term dustless blasting. That has really become a generic term that we hear a lot and we use it ourselves. It can be a little misleading. There's no such thing as true dust-free blasting. It absolutely reduces dust by a lot, but there's still a little particulate in the air when you're doing this form of vapor blasting. And in the old days, if someone needed to keep the dust down, and this really got started more with regard to blasting done outdoors, and even today, more and more municipalities and cities are getting very, very strict with any type of work that's performed outdoors that generates dust. So this vapor blasting is solving problems in various markets. But again, in the old days, you could just attach that nozzle that is shown on this slide to the end of your blast hose, and all of a sudden, you could use your dry blast pot and hook it up with this nozzle and do wet blasting. It's not the same as vapor blasting though. It's just keeping the dust down and not much else. And the consumption of water to use this arrangement is very high. It gets very messy very quickly. So the machines on the market today, they break down into really two categories. And the first category, the more popular category, is the premix system. And by premix, just referring to the ability to pour both media, in this case, let's say baking soda, and to combine it with water right in the pressure vessel at the same time. There is some advantage to that. It moistens the media better than the other style system, and that other style system is a hybrid, and they're out there. They work pretty well, and they do allow you to go back and forth between dry blasting and wet blasting. The key difference here is the water is injected at the base of the blast hose versus being combined with the media initially. And it still is performing vapor blasting, but it's not, in my opinion, it's still not quite the same as a true vapor blaster that's wetting the media in the pressure vessel. Next slide, please. So I mentioned, it's not a dust-free process. We represent the Graco line of vapor blasters called EcoQuip. Most of you probably recognize Graco, the name. They get involved with lots of different types of spray equipment and so on. So they do have the resources to do these kinds of studies. And when they did their data testing, this is the statistic they came up with. And we're very comfortable with this ourselves based on our experience. So we are talking about reducing dust by quite a bit, and 92% is what the Graco factory advertises. The other advantages of vapor blasting include the fact that when you all of a sudden are combining the water with the media, you experience better cleaning results. So you're using water as part of the cleaning process. It's not just keeping the dust down. It's adding to the efficacy of the process. If you're working on steel, this is another question that comes up a lot. How do you prevent flash rust from occurring? It's actually very easy today, and I have another slide in a little bit that'll talk more about that. And one of the larger benefits of this process is because we're doing things now differently, we are using a lot less media and water than a traditional dry blast pot would use. And I have some numbers for you on the next slide. There is a lot of versatility with this equipment, so it has a very strong fit into the reman process, but it also can be used on other kinds of surface preparation projects. The range, the pressure range is wide. So I know a couple slides ago I was using the example of trying to blast at 90 to 100 psi, and that is very common, but there also could be a scenario where you're blasting a very delicate substrate or something that's just fragile, let's say fiberglass. You probably don't want to hit that at 100 psi, and instead you would dial your pressure down to say 30 or 40, maybe 50, but that's still going to clean the surface, and it's not going to rough up the fiberglass in this instance. So you do have that ability to change your blast pressures dependent on your project. It's not a one-size-fits-all approach here. And a side benefit, something that was really discovered after the fact was, so if we are using baking soda to do the cleaning and blasting, we never ever have to worry about heat buildup, even if we're going dry. That's the nature of soda, as Brian mentioned, the friability factor. However, these machines can also be used for traditional abrasive blasting, and in that situation, you would never dry blast a thin piece of sheet metal. It would stretch or warp and get ruined very quickly. All of a sudden, when we add water to the equation, we can use a hard abrasive on a thin piece of metal and not damage it. And we're running into companies more and more where they're finding that to be of significant value. So there's always a couple cons to any new process, and actually I don't think these are too serious. In terms of it still involving water, well, like I said, we now have the ability to add a rust inhibitor into the solution very easily, so that takes away the risk of flash rusting. There's still sometimes where we know you may not want to have any risk of water infiltrating a compartment, and you might not be able to mask it off or remove it. We find that especially on older style equipment. So there are times where water might be a no-no, but that just seems to be less and less of a problem. And then there's still some cleanup here, but not as much as you might think. And I'll explain why in the next slide. Go ahead, Brian. So if you're in the market for a vapor blaster, right, what we think matters most is, first and foremost, make sure the vapor blaster utilizes a water pump to pressurize the system. For vapor blasters, that really is the heart of the engineering behind these. There are some vapor blasters that choose not to use a water pump, and we find those to be inferior because they really are just dry blast pots, and they're using water to keep the dust down. But you don't gain any efficiencies. You're not using less media, and you're still using a decent amount of water to achieve the dustless effect. Graco does offer a way to meter the media electronically. I personally haven't seen that on any other system out there. It's a really good feature because it allows you to fine-tune your media consumption a lot better than you could ever do manually. And it also just helps track cost and track operator efficiencies and so on. The vapor blasters that use a water pump can run soda. I mean, that's the topic of today's webinar. But there are, like I said, there's some blasters out there that are not using the water pump, and they cannot run soda through them. So we would recommend avoiding those. If your interest is vapor blasting with soda, you need to be looking for one that uses a water pump. Another nice feature to have, so any type of blasting, vapor blasting operation, you blast first, and then you still have to perform a rinse down, including soda blasting. Soda is actually easier to rinse down than the other abrasives. It is water soluble. It rinses away rather easily. And being able to just flick a switch and to go into washdown mode is a time saver. And then here are the stats on consumption. What you're seeing here are worst case scenarios. So we have a lot of these machines out in the field at our customers, and we typically get feedback where it's rare if they're running it at 150 pounds per hour. It's more common these days to hear people tell us they are using maybe 100 to 110 pounds per hour, and that is not a lot, and especially when you compare that to traditional dry blasting. The water usage is also, this is worst case, 15 gallons per hour. It's more common to be using 10 to 12 gallons on an hourly basis. And if you are actually at the nozzle using one of these machines, there are times where it's such a mist, it's hard to see the water. That's how well engineered these systems are. You will not see any pools or puddling collecting on the floor. It really is minimal. So, there's an ROI to this technology, and that's an exercise we're happy to work with people on. And it goes beyond, just less media and water usage. You need to factor in, if I'm using less media, I'm not using, or I don't need to dispose of as much media, spent media. And typically, a lot of the operations we're involved with, that waste stream is non-hazardous. It always depends on what you're removing and your local authorities, but by and large, that's our experience. The waste that's generated is non-haz and easy to dispose of. Next slide, please. So, mentioned flash rust before. This is the product to use. There's a couple others on the market that we've tested. We find Hold Tight 102 works the best. It's very, very eco-friendly, fish safe, operator safe, you name it. It's a non-hazardous solution. It has a very high dilution rate, and it opens up a window. So you can blast steel, and if you're using Hold Tight, you have at least 2 days to get around to repainting it. And depending on your climate and the humidity levels, you may have a little bit longer, but you definitely have at least 48 hours to get to the recoating step. This product, if you start to Google it and research it, you'll find it's been around for a long time. It's been used by major organizations, and by the way, it actually helps the rinsing process if you're soda blasting. So Hold Tight is a salt remover too, and sodium bicarbonate obviously contains some salt there. So using Hold Tight during the washdown process after soda blasting just helps ensure every ounce of soda gets removed, and it actually just speeds it up. Your washdown goes a lot quicker if you use something like Hold Tight. Next slide, please. So we're going to move on now to how do you contain everything, especially if you're trying to do this process indoors. Outdoors, actually not going to speak to that really at all. If you are currently have a sandblast operation outdoors and you're doing everything dry, quite frankly, to convert over to a vapor blasting operation in the same spot would be really, really easy. The going indoors, it's a little more involved, but the company, so a couple of the pictures you're going to see next are pictures of the project that we installed this year. And this company, again, is located in Illinois, so it gets cold up there. But they also are, they just had no interest in even trying to do anything outdoors. They wanted to control the process, and by and large, blasting operations conducted indoors allow you to have a little more control over everything. The system, so this whole containment system, it absolutely replaces a traditional dry blast booth. So this same company where we did this project, they own 2 other facilities where they already have traditional dry blast booths installed. They do a lot of aluminum work, These other facilities that they currently operate are set up to run steel shot. And if you aren't careful, the combination of steel shot dust and aluminum dust can become very hazardous. And if it reaches a certain concentration point, it will explode. The insurance companies know all this. So anybody with this type of setup is going to be paying a premium to make sure that they're covered properly. So this is actually one of the reasons our customer wanted to get away from dry blasting and start to do vapor blasting. That risk, that explosion risk, has gone away. It's just not there anymore. This also can replace salt baths. I know they're not as popular as they used to be, but they're still out there. And this whole process can do away with that method. And then for folks that might have a smaller shop or just have a need to do small parts blasting, small componentry, you don't necessarily need to build a booth. You may have in your shop already a glove box or a sandblast cabinet. The picture on the lower right is showing you a glove box designed and engineered for wet blasting. So you just don't see the vapor blaster next to it, but that's the cabinet itself. There is no extra equipment required, no extra vacuums or dust collectors. That's it. You just need that cabinet plus a vapor blaster and you're in business. But that's perfect, again, for smaller parts and pieces versus, trying to do that in a larger scale environment. Next slide, please. So here is the containment system that was built from the ground up. It does consist really of two portions. So the Hydropad is the floor, and you see the green floor with a lot of grooves. That is the Hydropad. The enclosure, you might be thinking, geez, that looks a lot like a paint booth, and it actually is a lot like a paint booth. It's been modified. Its filtration system, its ventilation system has been modified so that it can handle the mist that's generated versus just plain dry dust or vapors. And then this has been modified to integrate seamlessly with the Hydropad. So it is sitting, on top of the Hydropad there. That's the way it's been engineered. We do receive a lot of questions from folks trying to see what they can reclaim, if anything, with soda. Again, it's water soluble. It's never been designed to reclaim. It's, a one-pass media. If we're talking more hard abrasives, we're not quite there yet. That is being worked on as we speak. How can you reuse the hard abrasive? But for the moment, our client is just disposing the spent media when they need to. They're also using soda actually quite a bit. So if you could go to the next slide, Brian. So this just shows you some close-ups. The Hydropad is modular, so you truly are just taking one section, placing it next to the other section and fastening it together. That's how that goes together, really easy and quick. And then the lower right picture shows the construction of the enclosure or the booth. And that also is modular and relatively quick and easy to assemble. The filters in this system are reusable, so that lowers the ongoing cost by quite a bit. They really just need to be rinsed out occasionally. And then the other two pictures are showing what happens to the waste. So the middle picture on the bottom, which shows the drum, that's where the solids end up. That chute is depositing the solids into that drum. And then the picture to the left is showing what is called a drag conveyor. It's really a gutter system. So if you go back to the Hydropad view for a second, you'll see the grooves in the green platform. Those grooves are collecting the waste, the runoff that gets generated. The Hydropad is installed on a slope, and that slope allows the liquid to feed into the gutter. And then once it hits the gutter, what's happening is the solids are separated from the liquids. So the system is sloped first to feed the water into the gutter, and then there's another slope on the gutter that allows the solids to be pulled upstream by the drag conveyor. And as it's pulling the solids upstream, the liquids are going downstream, and they eventually hit a sump pump, and that sump pump can direct the waste liquid into a separate container. It can also feed into a current wastewater system. You have different options depending on what you want to do. From a construction cost standpoint, it's much, much less than a traditional dry blast booth. Everything is above ground. There's no pit to dig. There's no excavating. There really are no construction permits that would need to be pulled if you have an existing building. Nothing's getting installed outside of your building versus, a traditional dry blast booth. You typically are installing a very large dust collection system outdoors, which includes a cyclone and so on. All of that goes away. This is a really simple installation and can be, and this booth itself was 60 feet long, so rather large, and 16 feet wide. Next slide, please. So I'm going to obviously touch on the safety. It's part of the system. If you're working indoors, what we find most corporations are doing are using an AirFET helmet, and that's the picture you see in the top. Pappers are also used, and there are different schools of thought on the pros and cons of both systems. It's typically up to the owner or the client to figure out what works best for them. But no matter what, that's your lung protection. You always still need to be wearing hearing protection, making sure your skin is covered up and so on. If you could go to the next slide, Brian. And this here just details out the AirFET system. What I like about these personally, I don't know how many people have blasted that are on the line, but if you're on that nozzle and it's summertime, it's physical labor. It can be hard labor, and therefore you're going to work up a sweat. The AirFET systems allow you to use a cooling tube, and that cooling tube really provides air conditioning in your helmet. It makes a big difference from a comfort standpoint, and a comfortable operator is a productive operator. So that's one feature of the AirFET system that a papper cannot offer. And then that bottom picture is showing something that's made by a company called Klemco. It's a wonderful device. It sits right inside your helmet, and it is there to detect the presence of carbon monoxide. So we've sold quite a few of those to companies. It's just a nice way to ensure that the breathable air is compliant and doesn't contain anything harmful. Next slide, please. So actually, just winding down here, this just shows you at a glance, most reman operations have other projects to do, even just general facility maintenance, equipment maintenance, maybe vehicle or fleet maintenance. But this technology, vapor blasting with baking soda, can be used to clean your forklift. It can be used to clean all sorts of different equipment and tools. without harming them. So again, to me, soda is a wonderful cleaning media. It can be very aggressive in the sense it's going to remove what's on the surface, but it's not going to damage or harm the substrate. And that to me goes a long way with regard to being able to clean things in an eco-friendly way and actually a very fast way. Soda blasting can be much, much faster than whatever your current process may be. So next slide, I think, is it, Brian? Yeah, so thank you all for your time, and we're here to answer any questions that you have.
Very good, guys. Okay, we have a few questions up already. From Tom Larry, does anyone have a video or something showing this process cleaning a Duramax head or other direct injected heads? Intake ports are packed full of oil and very time consuming to clean.
This is Brian here. On our YouTube channel, we don't have those exact parts, but we do have a Caterpillar engine being vapor blasted, so you can kind of see the results of that.
Yeah, this is Jeff. I don't have that specific video, but it's a great idea for us to do something like that. And actually, I'm writing a note that we could probably get that done pretty quickly and post it up on our YouTube channel as well.
Well, that'd be good. The diesel stuff that gets real gummy, it's very difficult to clean. I know from personal experience on that. From Christopher Chitka, does Hold Tight 102 have to be removed before painting?
This is Jeff. The answer is no. So the way Hold Tight works, it actually is creating an ultra clean surface. It's removing not just any salts from the surface, but also any other contaminants that you find on metal, say post-blasting. So it's not leaving a film. It's not leaving a protective film at all on the metal. Instead, it's just making sure everything else is removed. Blast rush develops when you have a unclean surface and then the moisture latches actually onto what's still left on the surface. Hold Tight removes any and all opportunities for moisture to latch onto it, and that's how it works, which means there's no film left behind, so you can just put your part in the paint booth and start painting it without any concern that you need to do anything else.
Very good. Charlie Williams is asking, how does this do on gasket removal? Or did you have another comment on that, Brian?
No,
okay.
Not on Jeff's last question. Gasket removal, baking soda works great in removing gaskets, labels, stickers, paint, oil, grease, and any type of grime. All those in the above can be removed without any issue.
Okay, from Eric Nord. With the vapor blasting using soda, is the media one-time use? Meaning, does it go through the nozzle one time only?
This is Brian again. Yes, whether you're dry blasting or wet blasting, baking soda is a one-pass media. The reason for that is because when you're using a harder media, what happens is the energy of that hard particle, when it impacts the surface area, it actually takes a little bit of the substrate material away along with the contaminant. When a bicarb crystal hits the surface area, the impact is an explosion on the surface area. The energy is dispersed by the particle. That energy removes the contaminant, however, it does not remove substrate material. Because that bicarb crystal explodes, it's broken into, we're talking micro size here, 1,000 of mini type particles. That's why it cannot be reused, because it's no longer that 270 micron size anymore.
Okay, our next question, back from Charlie Williams. Does the unit use filtered water, or does filtered water work best?
Unless you have a severe problem with your water supply. Generally speaking, regular tap water is okay. If you already have filtered water, it cannot hurt, but usually our experience is that, you know, there's no filtering occurring before it goes into the vapor blaster.
Okay. Seems like questions are kind of winding down. Just a question that you might, or a comment you might throw out is, how much can you downsize this? Your examples were very large. A lot of these attendees are small shops that certainly wouldn't need a 16 by 30 booth. So how much can you downsize this operation?
A lot, Joe. So I mentioned it briefly with regard to, you know, there are now vapor blasting cabinets that are designed for small parts and pieces, and they're certainly much more budget friendly than a large scale operation. So that's one way to skin that cat. You could actually, you know, so that Hydropad, I forgot to mention this, that doesn't necessarily need to be mated up with the enclosure that I showed. It could be so you can use just the Hydropad alone. So if a shop has a small room that they think would be suitable to do a little blasting in, really you just need to make sure the ventilation is in place, and then you could drop something like the Hydropad into that room and do smaller components and cores and so on. There actually is today a wide range of both vapor blasters and containment equipment, and that's something we can help people spec out, but definitely you don't need to have such a large structure to do this process. Definitely not.
Okay.
This is Brian here. I'll give you guys an example. In Armex, we have a technical lab in Rocky Hill, New Jersey here. We have a 10 by 10 booth that we blast in as well. So, I mean, it really comes down to what you're cleaning, and you can really tailor the size of whether it's a blast cabinet or a blast booth to the size of your requirements. And a lot of your blast booth manufacturers out there, mainly on the dry side, you know, they can custom build sizes depending upon, you know, how big you need or how small you need. So these type of processes can be customized to whatever your requirements are.
And I'm assuming they can contact you for some direction on that, Brian.
Of course, no problem.
Great.
Yeah. And this is Jeff. Just to chime in, we have here at our facility a Hydropad. It's much smaller than the pictures, but it's a way for people to see it up close and personal, to see how it operates.
Okay. From Paul Straney, how is Hold Tight applied? Is it mixed with into the slurry?
Yes, it is. So the vapor blasters typically are mated up with a holding tank. So you would add the Hold Tight into the water tank, and then it's automatically fed through the vapor blaster.
From Timothy Slater, what estimate of time would be involved in blasting a cylinder head or engine block?
I could take the first hit at that one. It's actually very difficult to say, just because it really depends on what you got to take off. You know, is it burnt on carbon? Is it a heavy grease and oil buildup? It's very difficult to give you, I guess, a time, how long it takes. Give you a little bit of perspective. On the Armex side, we've worked with a customer out on the West Coast in California. They're a transmission remanufacturer. Prior, they had 5 employees hand scrubbing and wire wheeling the transmission housings. It would take them about anywhere from 15 to 20 minutes per housing per person. We've converted them over to soda. Now they have 1 operator doing what 5 operators did in the day, and it takes them anywhere from 3 to 5 minutes, again, based on how dirty and how contaminated it is to clean the housing. Blasting is very fast. It's really quite amazing how fast it is. And as Jeff also pointed out during the presentation, dry blasting is quick, but when you add water to the whole mixture, it actually even accelerates it even more. So it is a very high productivity type cleaning. So it's definitely something, worth looking into if you're doing things by hand now, or chemical cleaning, things along those lines. If you want to reduce resources and also increase the final, quality of the product you're cleaning, it's definitely something you might want to look into and explore.
Great.
And I would just add, I'm not sure where that person's located, but we do have the ability, if someone wants to really get down to exactly how long it takes for their part, because there are so many variables to this question, we're happy to, they can send us the part. If you don't live right around here, that's okay. You can just UPS us a part. We can videotape the process, and so they can still see it with their own eyes. It's easy now to just put that video up in the cloud, and we can do a time trial, and really, that gives, I think, people the best way to gauge how effective the process is. But that is an option that we offer for people that want to continue to explore this process.
Timothy has a follow-up question. Is there any automated process that has been implemented with this system?
I'll start with that and I can let Jeff pick it up. I have worked with probably 2 different remanufacturers that wanted to add a automated component to the blasting. Unfortunately, it's just not there yet. If you were cleaning a turbocharger, for instance, and it's the same size turbocharger with the same type of contamination, there are systems that can do a pretty decent job. It still needs to be followed up with a hand blast to get into certain areas. The challenge is that the optics aren't there yet to determine level of clean and what needs to be cleaned. The optics right now, imagine a square. It'll start in the upper left corner, go across, and kind of go, line for line, where, the one part is very good for Armex, but very bad for end users is the consumption of media is astronomical, how much media these systems use, because in essence, they're blind blasting right now. So unfortunately, from my experience, automation just isn't there yet.
I would just say ditto. I haven't seen anything myself yet that's being offered.
Okay, Mauricio Mendez. This system can eliminate the use of gas ovens to burn blocks and cylinder heads? That's a question, that's not a statement. Can this system eliminate the use of gas ovens to burn the block and cylinder heads?
Yes. Absolutely. It absolutely can. And actually, we were working recently with a powder coater who's also using a burn-off oven for a lot of their rework. But, the issue with that is it's damaging or ruining a lot of the metal that they're putting into the oven. So it's not only can it be used, it's safer to use for the part, and it's a lower cost operation than any type of burn-off oven that I'm familiar with.
Okay,
I would agree.
All right, again from Timothy. That's a great point. What is the width of the spray path for something like a crusty, dirty engine?
This is Jeff. So go ahead, Brian.
Okay. Give you guys a little bit of background. When soda blasting first started, dedicated soda blast equipment did not exist. When Church & Dwight first got into soda blasting, we actually designed, patented, and sold the first soda blast equipment on the market called AccuStrip. There are different types of nozzles out there, fan nozzles, Venturi nozzles. Honestly, it's our experience from all the years we've been doing it, and just so you know, we don't do equipment anymore. We actually sold off all our equipment to what's called, at the time, US Filter, now Axion Schmidt. We find that, if you're using a fan nozzle, for instance, you still have the concentration of the soda and energy coming out of the center part of the nozzle or the left and right part of the fan, you're not getting even cleaning. We find that a traditional circular nozzle is the best route for cleaning. And again, whether using number 4, number 6, or number 8, which is a 8 is a ½ inch, I believe, that's the type of soda stream that you can expect. A lot of people have the mentality that the bigger the nozzle, the wider the nozzle, the bigger the fan, the more swiping, cleaning you can do. It's actually contrary to that, because what happens is the more soda that you're expelling out the nozzle, you're in essence you're creating a more of a, I guess you say, a hostile environment. These bicarb crystals are hitting each other. You're losing efficiency. So there is a part of diminishing returns where once you surpass a certain nozzle size, you're actually hurting yourself, not helping yourself. I hope that makes sense. Jeff, anything you want to say on that? Or?
Yeah, I would just say I think that there is still lots of opportunities for using a fan nozzle if it's light-duty soil. And then it can make sense to consider using that fan nozzle because it will give you that wider pattern. Some of this gets into technique where you have one of the variables in blasting is your standoff distance. So even if you're using a smaller nozzle like a number 4 nozzle, if you stand back, let's say 12 inches, well, your spray pattern obviously is going to be much larger than a 1/4 inch. And then that gets into, well, do I have enough air to give me a higher blast pressure, because as I stand off, I'm losing some velocity. So I don't want to say it gets complicated, but there are some various things to consider. But I think, the original question is yes, there are all different types of nozzles, and it really goes back to what are you responsible for removing off the surface, and whether or not that's an easy chore or a difficult chore. That's how you kind of get around to selecting the right nozzle for the job.
All right, from Sam Kippenbrock. How much faster is the vapor blast compared to dry blast on the same type part?
I can.
Go
Want me to get this one, Jeff?
Yeah, go ahead, Mark.
I want to say it was 2 years ago, I was out at Graco's facility out in Minnesota. We are doing some product testing as far as cleaning goes. We did this in the paint removal world, not the grease and oil. We had a 3-foot by 3-foot steel panel that had a 20 mil dry film thickness of a coating on it. Both panels were identical. We dry blasted it, and then we wet blasted it, or vapor blasted it. The vapor blasting was 30% quicker.
Yeah, I would echo that. Our experience is it definitely speeds things up quite a bit.
Very significant, guys. Okay, I believe that wraps up our questions. Okay. I want to thank you, Brian and Jeff.